So, good morning to everyone. So, today we are going to see about Unit 1 in Information Theory and Coding. So, here we are going to cover the topic what is information and what is uncertainty and what is entropy and what is mutual information. So, these things are we are going to discuss about in this topic. So first, before going to the introduction, so we know what is information. Okay, so information theory and coding. So what is information? So here, the information is the source of communication system, whether it is analog or digital. Okay, so this information theory it is a mathematical approach to the study of coding of information along with the quantification and storage and communication of that information. So the performance of this communication system is measured in terms of error probability. Okay? So error probability means during transmission, we need to receive the errorless information, that is errorless transmission in between that sender and receiver. So here the errorless transmission is possible only when the probability of error at the receiver approaches is 0. Okay. So, for example, we are going to send the amount of information to the receiver. Once a receiver receives that amount of information, the same sent by the sender, only it is a errorless transmission between the sender and receiver. Okay, so this performance of the system depends upon the available signal power, it's a noise and bandwidth. So the performance maximum depends upon the signal power. Main is the signal strength and noise and bandwidth. So based on these parameters, it is possible to establish the condition for errorless or lossless transmission. So these conditions when they referred to the in Shannon theorem, later we study. So this information theory is related to the concept of statistical properties of messages or sources and channels and noise interference, etc. So this information theory is used for mathematical modeling and analysis of communication system also. So with the information theory, so the modeling of communication system, the following 2 points are, it is very, very important. That are the main 2 points are irreducible complexity below when the signal cannot compressed. Then the second point is the transmission rate for reliable communication over a noisy channel. So these are the 2 important points for modeling the communication system. So then we move to uncertainty. What is the uncertainty? Normally, we said the uncertainty is situation often arise wherein a decision must be made when the results of each possible choice are uncertain. So that means here uncertainty means here. So consider one source or the source, it is x. We denoted the source, it is x. It is equal to x0, x1, x2 up to xnk minus 1. Okay. Then the various symbols x have the probabilities, the corresponding probabilities of this x is, we said it is p0, p1 and p2, etc. up to. Okay, that means the p of x, it is equal to xk. So this is the source. It have a discrete symbols x0, x1, x2 up to xk minus 1. The corresponding probabilities of these symbols are P0, P1, P2 up to Pk minus 1. Okay. Then, so these probabilities which are be written as, it is a P capital X, it is equal to X suffix K. It is Xk. So it is equal to Pk. So here K represents 0, 1, 2 up to K minus 1. So this set of probabilities should satisfy the following condition. So these probabilities should satisfy the following condition, that is summation of k is equal to 0 to k minus 1, pk it is equal to 1. So the summation of all the probabilities, it is equal to 1. So this is the condition. So such information we already discussed. So it is called discrete information source. Then this idea of information is related to it is uncertainty. So or surprise. It is uncertainty or surprise. So here we can consider it is consider the emission of symbol x is equal to xk. So x is equal to xk. So here we can consider this capital X. Capital X means here it is a source. Then xk means it's a discrete symbols. So xk. So we, from the source. So if the probability xk is pk, it is equal to 0. Suppose the probability of xk is pk is 0. Then such a symbol is, it is impossible. Okay. So similarly, when the probability pk it is equal to 1, the probability pk it is equal to 1, then such a symbol is sure. It's a definite. So in both cases, there is no surprise and hence no information is produced. Okay. So when symbol xk is emitted, the xk is emitted. Xk means here it is a discrete time symbols. K represent 0, 1, 2 up to k minus 1. Okay. So the probability pk is, suppose it is low, then there is more surprise or uncertainty. Okay. The probability it is very low, there is more surprise or uncertainty. So before the event, this x, capital X, it is equal to xk, it is emitted. There is an amount of uncertainty. So when the symbol xk, x equal to xk occurs, there is an amount of surprise. That means the symbol x, it is equal to xk, there is an amount of surprise. So after the occurrence of symbol x equal to xk, there is the gain in amount of information. Okay. So here the amount of information means here nothing. The amount of information transmitted through the message mk. That means normally we represents the message in small m. Okay, so that is mk means the messages with the probabilities pk. Okay, so the amount of information is it is mk. It is the total amount of information. So here we can consider. So see this, the amount of information. So here in communication system, normally it transmits the messages, the number of messages or k number of messages, M1, M2, M3 up to Mk. The corresponding probabilities are P1, P2, P3. So the amount of information transmitted through the message Mk with the probability Pk is given as it is amount of information Ik it is equal to. So this is total amount of information. It is equal to log 1 by Pk to the base 2. Okay. So here Pk represents the probability of corresponding message. Okay. Then unit of information here in this above equation log 2 1 by 2 log 1 by pk to the base 2. So again we are not able to directly calculate the log 2. So we convert this into log 10 log 1 by pk to the base 10 divided by log 2 to the base 10. So it is equal to log 1 by pk to the base 2. Okay. So normally the unit of information is a bit, number of bits. So we are using the term bit as an abbreviation of binary digit. So here we will see a new abbreviation BINIT for binary digit, bit or binary digit. Okay. So the total amount of information Ik in bits. Okay. So this is the definition of information. Then what are the properties of information? So these are the following properties of information. There is more uncertainty about the message. Information carried is also more. Okay, suppose the uncertainty is more, information carried is also more. If the receiver knows the message being transmitted, the amount of information carried is 0. Okay. Then the third one is if I1 is information carried by the message M1, then I2 is the information carried by the message M2. Then the amount of information carried the combinedly due to M1 and both messages M1 and M2 is I1 plus I2. So this is the amount of information. The total amount of information, it is equal to I1 plus I2. I2 is the information behind the M1, and I2 is information behind M2, and I1 is information behind the M1. Then next one is if there are M equal to 2 power n, equally likely messages. So M on the messages, equally likely messages, that means 2 power n. So then amount of information carried by each message will be capital N. It is bits. So these properties we will prove later. So here one simple example. The first example is calculate the amount of information if pk equal to 1 by 4. Okay. So here calculate the amount of information. So the amount of information formula is we know ik equal to log 1 by pk to the base 2. Okay. So I already told we are not able to directly calculate the log 2. Okay. So we convert this into log to the base 10. So log 1 by pk to the base 10 divided by log 2 to the base 10. Okay. So here the given in the problem, the probability is given in the problem 1 by 4. So we can substitute this 1 by 4 in this equation pk. So pk equal to 1 by 4. So log 1 by pk means here 1 by 4. Okay. It is log 1 by divided by 1 divided by 4. So it is going to the numerator. So log 4 to the base 10 divided by log 2. So the same thing, log 2 to the base 10. So it is equal to, so we calculate this log, we received 2 bits. So the output is ik is, it is 2 bits. The example 2 is here calculate the amount of information if binary digits or bits occur with equal likelihood in binary PCM. So here the P1, we know that binary PCM, that means pulse code modulation, only 2 binary levels, zeros and ones. Okay, so since they are equally likelihood means their probability of occurrence will be P1 in 0 level, it is equal to P2 in 1 level. So the probability is because 2 symbols. So it is equal to 1 by 2. The probability is 1 by 2. So hence the amount of information carried will be, it is I1. So we are going to calculate separately in the first one and second one. So first one I1, it is equal to log 1 by P1 to the base 2. So here P1 is P1 and P2, it is equal to 1 by 2. So we here substitute the P1 1 by 2 and P2 also 1 by 2. So we get the log 2 to the base 2 and log 2 to the base 2. So here I1 equal to I2 equal to log 2 to the base 10 divided by log 2 to the base 10, it is equal to 1 bit. So this is the correct identification of binary digit in binary PCM, pulse code modulation.